Taylor Flaxington. She's one of our experts in digital engineering, as well as Lieutenant Colonel Will Woodward, who has done some fascinating things with a challenge led by AFWERX and being able to bring some interesting technologies to fruition. So Taylor and Will, thanks for joining us. Over to you.
Thanks, Colonel Diller. All right, as he said, I'm Lieutenant Colonel William Woodward. I'm the Analytic Modeling and Simulation Team Leader in the Air Force Warfighting Integration Capability. So work with BB, who just talked about energy. And together with Taylor Flaxington, who's the Digital Engineering Lead for the Advanced Battle Management System, we're going to introduce Gaming Prime and its corollary, or its relationship with digital engineering. We're asking that as we talk about how gaming is currently applied in various forms throughout the Air Force, you think about our shortfalls, where we can do better, where can industry in the audience and otherwise help us, the Air Force, improve our approach to digital engineering and gaming. I want to put a picture on the screen. This is what we want a Gaming Prime program to create. And maybe that's surprising. It doesn't look very digital. It doesn't even look very modern. And really it's not. But this is a cutting edge technology tool for learning. And that's what Gaming Prime needs to go after. This is a wind tunnel built by Orville and Wilbur Wright in 1901 to test their ideas about how to fly, to test them quickly and cheaply and safely and systematically. And that's why we game military concepts and capabilities. And we think there's enormous potential to do it better. So I want to take a few moments to talk about definitions. What do we mean when we say gaming? To be honest, we're not entirely sure, but we mean it in the broadest possible way. Gaming means wargaming. It means visualization, augmented reality and virtual reality. It means prototyping and experimenting and exercising. It definitely means modeling and simulating. It means digital engineering and ideas like digital twins. And with that, I want to turn it over to my colleague Taylor to talk about digital engineering. Taylor, all yours.
Thanks, Will. So to your point about definitions, it kind of all started in 2018 with the Office of the Secretary of Defense releasing the Digital Engineering Strategy. And this document identified digital engineering as a paradigm shift from a design, build, test methodology to a model, analyze, build methodology, specifically defining digital engineering as an integrated digital approach to support lifecycle activities from concept through development. And more recently, Dr. Roper, Assistant Secretary of the Air Force for Acquisition, Technology, and Logistics, reiterated the need for digital engineering as the Air Force moves towards a new digital acquisition reality. The idea stated by Dr. Roper is not just to build better systems, but build systems better, more effectively, cheaper. And so what we want to know is what is an integrated digital approach to modeling, analyzing, and building systems better? As digital engineering has taken root across the Air Force and the DoD at large, this has come to mean many different things to many different programs, as digital engineering is a continuum across disciplines. Programs like Ground-Based Strategic Deterrence, or my own program, the Advanced Battle Management System, recognize that the more complicated and integrated a system, the greater the need for digital engineering. And so for ABMS, this means the application of model-based system engineering leveraged for analysis of shortfalls, pain points, bottlenecks to inform things like funding decisions or capability integration and development. This approach uses digital engineering tools to support elements like requirements traceability, architecture definition, cost analysis, high fidelity modeling and simulation, and campaign level simulation. However, digital engineering is just one piece of this larger gaming umbrella. And this includes tools and capabilities to support activities from concept to disposal. So I'll turn it back over to Will to address other ways in which gaming is used throughout the Air Force.
Thanks, Taylor. All right, let me talk about why we game, or why we digital engineer for that matter. Sometimes it's to teach or to train. That's what a flight simulator is for, to help a pilot learn how to deal with potential emergencies without being actually put in an unsafe situation. We can think of this as gaming to look at worst case scenarios, black swan events. Sometimes we game to forecast. That's wargaming in operational planning is for, to gain some understanding about the consequences of a set of actions. That kind of gaming, it needs maximum realism, both from the human participants and the supporting machines. Sometimes we game to explore. Maybe that's an experiment with a new technology, like the Advanced Battle Management System, to see how it might fit into the existing force. Or maybe it's an exercise that tests hypotheses about our ability to communicate and collaborate with allies while competing and engaging in conflict with adversaries. And that exploratory kind of gaming, it needs creativity to push the boundaries of what seems possible and wrestle with the widest range of inputs and outputs. So all of these types of games, training games, forecasting games, exploring games, they're about learning more, learning faster, learning cheaper, learning more safely, and doing it systematically and capturing all of the lessons, all of the data. And that's why we know that we need to do it digitally. I like the way that Dr. Roper said it in September in remarks. He said, we need to, quote, computerize or virtualize everything about our development and production, assembly, even sustainment of systems, so that we can finally get past the tyranny of the real world and take learning and feedback into the digital one. So gaming is definitely about storing and transmitting information accurately and systematically, and with compelling visualization to communicate. And it's about letting machines do the parts they're good at, and the humans do the parts they're good at. And it's about getting away from the general and averages and being precise and specific while still retaining enough clarity to move forward in decision making. So we're looking forward to a discussion tomorrow afternoon. And thanks for your interest.
So listen, yeah, Brandon, I know I was trying to interrupt you. This is a hard one to stop talking. It's very difficult to stop talking about. It's so exciting. It is learning. It's more exciting than learning. That's what it does. Digital learning, doing it fast. So thanks so much.